So welcome everybody to this session on resilient islands in Indonesia. You have seen already the video with the speakers, and I think it would therefore be nicer to start with an overview of the program for today, which is shown here. So the topic is resilient sustainable energy supply on islands. And our program is shown here. So we have 4 speakers today. To start with Penny Estianti Marcella from PLN, who is running a very interesting sustainable island project for the electricity company that provides all electricity in Indonesia. Then next, Max Ammer, the chair of the Raja Ampat Research and Conservation Center, will present about sustainable hydropower and sustainable developments in West Papua. And then thereafter, Kunaifi, who is almost a doctor at the University of Twente and also working in Riau University in Indonesia, will present about the research he conducted in the past 4 years on the implementation of PV systems and experiences with electricity grids in Indonesia. And then as a very last speaker, I will present about PV applications and how they might be of interest to Indonesia with a focus on systems, PV in the built environment and solar power mobility. So having said this, I think it would be best to proceed with the first speaker, Ms. Penny Estianti Marcella. So I will just stop sharing the screen. And Penny, the floor is yours. So you can share your presentation by your own laptop. And just in case it doesn't work with the connection, I also have it on my laptop. So, but I think it's better you start with from your side.
All right, thank you. So I will share my screen. All right, before I start my presentation, I would like to say hi to every audience in here. Hi, everyone. First of all, I would like to introduce myself. My name is Penny Estianti Marcella. I'm representative of PLN Bangkoblitu. So in this lovely day, I would like to share a little bit about PLN Bangkoblitu experience with the island electrification program in Bangkoblitu. Before I talk a little bit further to my presentations, I would like to introduce a little bit about what is PLN Corporate itself. PLN Corporate is a state-owned enterprise BUMN engaged in electricity sector, which is integrated throughout Indonesia, such as like from Sabang to Maroke. If you know that Sabang is a very beautiful island, you can see from the picture. And also PLN is the largest utility company in Southeast Asia by asset and its customer. Our core business is power generations, transmission and distribution, and through the customer service. And about PLN Bangkoblitu itself. So in Bangkoblitu, it's like a small island, but it's a complex island because it contains 2 main islands, Bangka Island and Belitung Island. The economy in here is agriculture, mining and quarrying and tourism. You can see in this slide that there's so many beautiful beach, sand, white sand and everything in here. It's a nice place to visit. So back to the topic. In here, in Bangkoblitu itself, our electrification ratio in Bangkoblitu is 100%. Even we have smaller island that didn't connect it to the main island, but the electrification in here is 100% electrified. We have 381 village and all of the village is electrified. In here, I would like to share how we electrify all of the island here from the big island until the smaller one in our remote area. So, like I said before, in here, there are so many remote islands that it's really hard to access by the electricity. So we have, of course, to electrify that island, we have so many issues and challenges. One of them is our population are spread across of 10 islands. We have high cost of energy because most of the island using diesel power plant in the past time, but now we moved to renewable energy. And also before, our reliability and of our existing renewable energy is still low, but we have made an improvement in there. So it helped us a lot to to share the electricity, especially in remote area. And also, we have limited access to electricity for inhabitants, such as like Pongo Island. It's very small island, like maybe only two or about 10 or 15 household in there, something like that. So it's really challenging. And how we overcome the problems, we do so many things, but I will summarize most of top of our solution for that problem. The first one is we make the energy transition through a rapid and efficient increase in new renewable energy. So we are massively making and building renewable energy for the power plant in remote areas, such as especially PV, because in Bangka Belitung itself, the potential of PV power plant is really amazing. And also we optimize not just PV system, but we also optimize the other renewable energy, and such agro waste by biomass and biogas. And we improving, we make a hybrid between diesel and solar power plant to make it more reliable for some area in our regions. And we accelerating and adoptions the mastery of technology of renewable energy, and encouraging electric vehicle and electric induction stove. As we know that Bangka Belitung itself is not a modern city, so many people still use like the old stove. So we engage them to use electric stove, so it will increase our demand. So it will be balanced between the demands and our productions. And our pilot project that time in Buku Limau, the whole household in there changed from oil to firewood cooking stove using the electric inductions since 2018. Here is our current energy mix in Bangka Belitung. For now, it still supplies 60% by coal power plant, but we have a project to reduce it a little bit. In the future, we will increase our renewable energy supply from now from 5.2% and to 25% in the future, in the near future. And you can see in this diagram about almost 80% of our energy consumption is still coming from diesel, and it make our cost productions higher. That's why we are committed to reduce the use of diesel power plant in Bangka Belitung, and we focus more on renewable energy. We have a massive project to build renewable energy power plant in here, especially PV system, because solar PV is very promising for Bangka Belitung. We have already studied about it, and we already see the impact of using PV system in Bangka Belitung with our cost productions. Here, our existing renewable energy in Bangka Belitung. Like I said before, it's still small number, but it will increase in the near future. So far, we only have 15.8 megawatt, or about 16% of our total capacity of electricity productions. This data is from July 2020, are coming from renewable energy. Here we also have biogas, biomass. So in here, we're not just focusing on PV system, but we also find the maximum potential of local resources for the energy. Here, the excited one. Like I said before, we have several power plants. It's spread in Bangka and Belitung. In Bangka itself, we have Pongo and Calagen. The capacity is still small, but it will upgrade soon. So far, the capacity is still 126 kWp, and for Celagen, only 100 kilowatt. And for Berlitung, the capacity is still low, but we are working on it. We have in Buku Limau and also in Gresik. Here, our roadmap green energy in Babel. So in Bangkoblitu now we start from 5.1% for our renewable energy in 2020, but we will increase it per year until 2025. We will reach 25.1% of renewable energy, and in Bangkoblitu, 80% of renewable, about 60% of our renewable energy will coming from solar PV. And here is our solar PV development plan in Bangkoblitu. First, we only have 4 solar power plant, and in soon we will adding some more in Belinyu, Mindanao, Sumedang, Buku Limau, and Gresik, and so on. So it will be massive development of solar PV in Bangkoblitu. Here, I make a little bit price comparisons between coal, diesel, biomass, and solar PV. And if we depreciation expense is considered as a nominal average, so the price of the energy will be like this. For coal is still 1,300 rupiah per kWh, and the most expensive one coming from diesel, and the cheapest one is from solar PV. So yeah, I think that's all from my presentations. I'll be happy if there's about the questions and answer. Thank you.
Thank you, Penny, and for this really interesting presentation that gives a good insight in the ambitions of PLN with regards to sustainable energy supply on islands. I think we have 1 minute for questions. So if somebody in the audience wants to ask a question, please type in the chat window, and I will read your question for Penny and she can answer. I believe that your presentation was very clear, Penny. So thank you. There's no questions in this stage. And yeah, with that information, we can proceed with the next speaker, who's Max Ammer from Raja Ampat Research and Conservation Center in West Papua. I would like to ask Max, do you want to show the video from West Papua to this session, or shall I put it on and move forward through the slides for you?
I'm not so good with computers, as you know, so if you can help, that would be very much
appreciated. I will put on your presentation, and then if you move from one page to another, then you can just ask me to go to the next slide.
Yeah.
1 second. Close this one. And
let me, and I don't know.
Well, this could work. Can you see this?
I think so.
No. So the floor is yours, and just tell me when to move to the next slide.
Okay, thank you very much. Different than the other speakers, I live and work in West Papua, and I work on diving tourism. But we have other projects also, like we have what we call the Raja Ampat Research and Conservation Center. We do kayak for conservation, and we do something in aviation. But we're very concerned about the environment, and that's actually why we got to know each other. I can say that I was very much helped by some of the other panel members with knowledge and ideas. And what I want to do is talk a little bit about my experience when you work in a place like Papua. I do not know, of course, everyone that is listening, but Indonesia and other cultures, of course, very different. So when we started the resort in a remote area, we needed to build all the systems. There was no water, electricity, or let's say sewage system or things like that. So we have to kind of invent it kind of by ourselves. So this is maybe for Indonesians quite normal, because in some areas it's not very developed. And I have to also congratulate actually Penny when I see what she has been doing, and the PLN is actually quite amazing. I'm really very pleased to see that they go to renewable energy more. But we ourselves had to find ways how to do this. So if you work in another culture, like the Dutch in Indonesia or the Indonesian and Dutch, maybe a little bit less, but things are very different. And I want to illustrate it in a funny way, maybe, because years ago when we started as a dive operator, I was standing in the center of the town of Sorong, and I had some travelers that I just collected from the airport. Now, I told the people that, next slide, please. Okay, next one again. This is the Raja Ampat from above. It's very pretty, as you can see, beautiful islands, reefs, and things like that. The next one. I told them that you cannot find, no, can you go back? That was really meant to be. It's a funny slide, a strange slide. I told them it's very difficult to buy toilet paper in Sorong. And as a Dutch, they couldn't understand that. They said, that's not possible. The guy I spoke to, he looked at me and he thought I was crazy. And he said, I will buy the toilet paper. So he went away to buy toilet paper. I already told him you couldn't find it. So after maybe 45 minutes, he came back with a tissue, because that's the only thing he could find that looked like toilet paper. And that was the only thing available in Sorong. I just tell this to illustrate that if you work in another area, and it's a little bit strange for people from the Netherlands, that some things might not be available and things are different. And it sounds very strange to you, but it doesn't mean it's worse or it's bad. I actually think that the way Indonesian use a restroom is a better way than the Dutch. It's just different. But it's sometimes a very different idea that people have. So I think it might be very strange, but it is something you have to understand if you work in another country. Okay. Then the next one. Yeah, through a Japanese organization, we were working a little bit with PV panels. Of course, like you all know, this is a very good way to generate energy. It's a good alternative. In Papua, it's maybe not so wonderful as some other places because we have very little open space. Of course, there's ways that you can put it on roofs and things like that. And that's one way. But next to working on the islands, we work also in the interior, the main island of Papua. And I wanted to talk about a little bit about other alternatives than PV, because Papua, different than the Netherlands, for instance, the Netherlands is very flat and you don't have height difference, but Papua is full of mountains with a lot of rainfall and a lot of rivers. So one thing I wanted to talk to people listening is that I believe one of the best source of energy for West Papua, for the mainland, is next to PV in some areas, also high head hydroelectric power stations. So that is actually something I wanted to ask your how must I say it, your attention to. I think that this is something that is not very well understood. There's a few high head hydroelectric installations in Papua, but not very many. Well, I feel that is actually very sad, because I think that is one of the best ways to reduce our carbon footprint. It's sometimes very difficult to know what is the best way to go. You know, we have theories like we have been building for some time some catamarans, like you can see in the picture, and we use diesel engines, but we're also building one that is fully autonomic on PV panels with, of course, batteries and electrical engine. And we were helped very much by students from Dutch University, actually through Ibo Angela. She helped us with connecting to these people, and it was a very wonderful working together. The people involved were really very enthusiastic and did an excellent job. They helped us to understand a lot of things. And the result of this working together is that we now set up a small boat building workshop as an education center. And we work on two things. We work on the diesel power boats, and we work on the electrical power, the PV powered boats. At the moment, this electrical powered of the diesel powered boats are only using 1/3 of the energy that our former boats were using. So we have reduced our power use 2/3. That's a very big saving, I believe. And because there's many boats in Indonesia and a lot of sea, a lot of islands, I believe this is a good thing to keep on going. And we hope to develop more and different models of boats and to help in this respect. But I have to thank universities to help us with ideas and with support. And the result is this boat. So please, could you show the little movie?
We started building the first fiberglass boats in Dutch Upland about 20 years ago. Years, we're not only able to build fiberglass boats for ourselves and the local community, but we were also able to train a number of our top-line staff to be able to build their own fiberglass boats. The aim to enable them to start their own fiberglass building companies. Our boats are now being used by conservation organizations, local people, government institutions. This year, we'd like to introduce you to our newest models. First catamarans built in Raja Ampat by the people of Raja Ampat. Models are designed to be as environmentally friendly as technically possible, while providing more comfort and safety for passengers. Way less people than our normal boats, so we're very happy to switch over and from capable and most customized. We are always trying to work in a most environmentally friendly way.
So unfortunately, I think the video doesn't come through very well, but what I'm trying to explain is that the savings on fuel are really tremendous, and the working between Ibo Angeles University and our organization has resulted to some good developments, I believe. So that's why I'm happy to speak to you, and I hope that in the future we can do that again. We are now working very much in an area called Tamrau, and the biggest need I see there is help with realizing high-head hydroelectric energy. I believe in that area, especially, it's very useful, and it's what I understand to my best understanding is it's the greenest kind of energy you can have. Different than PV is that, of course, the water runs 24 hours, 7 days a week. So you have power at all times. Also, when you have hydropower installations there where there's many possibilities for it, you also have the possibility, you have the advance that you don't have to transport your energy for over a long time. So you reduce the, let's say, the power, the high power, how must I say, the high power lines that you normally bring in. And if in Indonesia or a country that has a lot of forest, if you make roads or you make power lines, often there's access to an area. Then what happens, which is not so wonderful, is that people start logging. So you immediately get environmental damage. So if you could realize high-head hydropower installations, because you could take the power close to where you actually need it, you need much less power lines, and you have less loss and also less cost. So I want to try to get the attention of the listeners here to consider high-head hydropower as a very good alternative next to PV panels. Of course, on little islands, you don't have any water there, you can't have hydropower, but on bigger islands in Indonesia that has a lot of mountains and a lot of rain and a lot of water, I believe high-head hydropower is one of the ideal things. And then I want to end with a little remark. It's like this: I learned something from my dad, and that was, he told me, cannot sleeps in a graveyard. And then he said, will not is laying next to cannot. What my father tried to tell me is that anything you want, if you put your head to it, if you put your will to it, you can do. So that's why I show this little helicopter. Is one of the things we do. We're a little bit into aviation. Some people said we were crazy, we could never build a helicopter together, but we actually did. So every student, every person that is working on something, remember, if you put your mind to it, you can do a lot. Never give up, go for your goals, and you will be successful. So that's my message to you. Thank you.
Thank you very much for this very surprising and inspiring presentation, all the way from West Papua. Of course, there should be questions. So I wonder if I stop sharing the screen, because otherwise I can't see the questions in the chat window. Whether somebody has questions. Okay. Are you sure that you don't have any questions? Okay, there is a question and answer session at the end of the presentations. So we will ask questions to you then. But for now, I would like to thank Max Ammer again for his presentation, and actually invite Kunaifi as the third speaker to set up this presentation.
Okay.
By screen sharing.
I'm trying to...
You can see it.
You can see it now?
Yeah.
Okay.
Please put it in full presentation mode. Yeah. Thanks.
Okay, thanks, Angel, and hello, everybody. Today, I would like to share with you about the implementation of PV system and experiences of end user with the grid in Indonesia. To start, Indonesia has been facing some challenges in providing a proper electric power supply to the whole population. The first challenge is due to significant variation between regions regarding access to electric power cells, price of electrical energy, and the reliability of electrical service by the grid. The second challenge is due to electricity consumption per capita in Indonesia that is relatively low compared to, for example, some countries in Southeast Asia, and even with developed countries in Northern Hemisphere. The third challenge is regarding power infrastructure development and climate change mitigation that seems to be conflicting with each other, where we know that the majority of the electricity generation in Indonesia come from coal power plants, while the progress with implementing renewable power system has been slow. Finally, amid fossil fuel reserve that are facing depletion, Indonesia needs a new approach in developing its power system to ensure energy security and sustainability. We believe that given its unique geography, the available renewables energy sources, and the high level of CO2 emissions, renewable energy is considered a rational option for Indonesia to secure its sustainable energy future. Is there any hope for solar PV in Indonesia? We know that potential for solar electricity in this tropical country is enormous. Penny has shown that for Bangkoblitu, for example. However, evidence regarding the suitability of PV system in Indonesia by research finding is lacking. Therefore, we would like to address an important question, which is a main question. would a transition towards solar photovoltaic system be feasible for Indonesia? We break down this main question into two sub-questions. First, what is the performance of PV system in Indonesia as compared to other climates? And second, what are the preference and attitude of end user of the electricity grid, particularly household? Let's start with the first part, the performance of PV system. In this presentation, the performance of PV system is represented by performance ratio, or PR, and performance loss rate, or PLR, which is also known as degradation rate. The PLR, or degradation rate, is a rate of change with a negative rate representing a decrease in performance. First, we evaluated 3 PV systems in Cirata, West Java. 2 systems use CIS PV module, and one system is from polycrystalline silicon technology. We found that the irradiance on surface tilted 10 degrees, ranging from around 400 watt per square meter to 1.25 kilowatt per square meter, which is very good. The daily average PV values for the CIS system ranged from 87% to 92%, which are also very good. And PR for the polysilicon system was 80%. This is also good performance, given that the system has been operating for more than 10 years. After evaluating PV system in Indonesia, we conduct another study by observing PV system in other countries. The purpose of the study was to compare PV system in Indonesia in terms of performance with PV system operating in other climates. The first location, again in West Java, the climate here is AF, or tropical rainforest. The second location is in Pekanbaru in central Sumatra. The climate here is also AF. The third location is in Bolzano, Italy. The climate in Bolzano is CFB, or temperate, dry summer and hot summer. And the final location is in Alice Springs, Australia. The climate here is BWH, or arid, desert and hot. From this location in Alice Springs, we use 12 PV systems from various types of module technologies. These are the results of the studies. This PR table shows the annual average performance ratio by climate. The PV system in Italy showed the highest PR with a value of 84%. A bit lower than that, PR in Australia and Indonesia has the same value of 81%. This table indicates that the PR of PV system in Indonesia is as good as PR in other countries that have developed PV system very well. This graph shows the values of PRR in the 3 climates. It is interesting to show that the lowest PR was experienced by PV system in Indonesia. Let me repeat that the PR of PV system in Indonesia is as good as PR in other countries. Moreover, the PLR of PV system in Indonesia is the lowest when compared to PV system in Italy and Australia. However, as shown in this last graph, the quality of installed capacity, the quantity of installed capacity of PV system in Indonesia is much lower than those in other countries. This opens a great opportunity for developing PV systems in Indonesia. Now let's move to the second part of the presentation, which is the experience of the end users of the electricity grid. To capture the experience of the grid user and to capture the attitude, we conducted a desk study, user survey, and measurement of the PLN network. However, the study was conducted 3 years ago, from March to April 2017. The study took place in 3 locations. First, in Pekanbaru, the capital of Riau province in central Sumatra, in the western part of Indonesia. The second place is in Kupang, the capital of East Nusa Tenggara province in the central part of Indonesia. And the last location was Jayapura, the capital of Papua province, the easternmost part of Indonesia. In the next slide, I will show a few results from the survey. This table shows the difference between the official report and the experience of households, the end users of the grid. The metrics from the official report were SAIDI and SAIFI. SAIDI is the average outage duration for each customer served in hours per customer per year. SAIFI represents the average outage frequency for each customer served in number of interruptions or outages per customer per year. The metric generated from the end user experience were PSAID and PSAIFI. So blues are what the official report had written, and reds represent what the grid users has experienced. As shown in the table, on average, when compared to the official report for the respective provinces, the users in Pekanbaru and Kupang experienced 2.6-fold and 3.9-fold longer duration, respectively. And similarly, households in Pekanbaru experienced 1.3 times more frequent outages per year compared to the value from the official report. In Kupang was even higher, which is 4.6 times higher than the official report. In short, the grid users experienced more frequent and longer duration of outage than the official report presented. In the next slide, I will show how grid measurement have confirmed this finding. We measured the grid in Pekanbaru, Kupang, and Jayapura to capture grid outage events. As shown, the number of outages in the official report for the whole province for the whole year of 2017 seems to be lower than what we have captured during a much shorter period of measurement. Responding to the frequent outage event they had experienced, this is how did the household responded to our questions. Most of households willing to pay a higher electricity bill for better electricity services. To avoid cost of outages, households were willing to bear a 10% to 30% increase on top of the existing monthly electricity bill, or around 1 cent to 3 cent dollar per kilowatt hour for improved reliability of the electricity supply. Also, the following figures show interesting results. Namely, most of the respondents actually in the 3 cities has some knowledge about PV system. And also, most of the grid users favor PV system on their houses rooftop. Now, this is the end of the last slide. To conclude this presentation, let us return to the question: would a transition towards solar photovoltaic system be feasible for Indonesia? We have witnessed that the challenges have been here for a long time now. The resource, the sun, is here forever. The technical evidence prove it, yes, it would. The hope from the people has been sounded quite loud since long time ago, and the moment is coming now. Therefore, I believe that solar PV will contribute to a significant share in the energy mix of Indonesia, realizing a transition from a fossil-based electricity to a solar PV and other renewable-based power generation. But this requires a strong willingness. Thank you.
Thank you very much, Kunaifi, for this very extensive and clear presentation. I would like to mention also that apart from this presentation, Kunaifi has published a book with Springer, which represents the content of this presentation in 120 pages. The good thing is that I already received a question during the presentation of Kunaifi, and that's a question that maybe is posed by everybody if you know the situation in Indonesia. Because the question is, and Kunaifi please answer, because this energy source is environmentally friendly, why it's difficult to develop? Why we use a lot of fossil fuels for electricity? Is the problem with government policies or the high price of technology? And the question was asked by Henry Nasution.
Thank you for the question from Henry Nasution. I think this is a very important question, which is also question that has been asked frequently. And this is a good thing. We have renewable energy, we have a PV system in particular, but why is it difficult to develop? Why are we still using a lot of fossil fuel for electricity? We need to admit that fossil fuel has been doing a lot of good thing for us, for developing humanity from more than hundreds years now. However, we also realize that fossil fuel bring a lot of problems, including environmental aspect, and also the reserve for the fossil fuel is not there every time. So it is they are depleting. In my point of view, there are a lot of factors that cause why this not developed yet in Indonesia. One of the main issue for me, the main cause for me is regulation, because this is a new thing. When you introduce a new thing, something you need to take about a little bit special. For example, you give subsidy for fossil fuels, and then that means you need also to give subsidy for renewable energy, so they can grow together better. And also the high price normally will go down when the market size is going up. And as we already witnessed, that the price for wind, the price for solar PV, and the price for many other renewable energy technology has been going down very rapidly. So I think that's the answer.
Thank you, Kunaifi, for your extensive answer. And yeah, indeed, it's a very complicated dilemma, which is related to policies and strategies, but it's not determined by the performance of PV systems in the tropical climate. So also given the time, I would like to ask everybody to postpone further questions to the question answer moment after the fourth presentation, which I will give. So sorry for changing roles. I have to share my screen. Yeah. Is it visible?
Yes.
Kunaifi, can you keep track of my time? If I speak longer than 15 minutes, will you warn me?
Okay, I will.
Yeah, great. So, hello everybody. My presentation will be about PV applications, systems, PV in the built environment, and solar power mobility for the case of Indonesia. First, I would like to address the incredible potential of solar energy in Indonesia. Then I will actually explore the three different sort of approaches into using photovoltaics more extensively. And then I will conclude with some recommendations. So why it's so interesting to use solar energy? On the one hand, of course, it's a very reliable energy source. The sun rises every day. It's free, but it's also the largest energy source that we know on Earth. So every hour we receive as much energy from the sun as mankind uses in a year, and it's for free. So it's really interesting and relevant to explore how we can better use it. For Indonesia, you have a special situation because the location of the country at the equator causes extremely high solar irradiation on horizontal plates the whole year through. In most provinces, the irradiation exceeds 1800 kilowatt hours per square meter per year. And I just would like to compare that with irradiation in the Netherlands, which is just 1000 kilowatt hours per square meter a day. And in some provinces, it's even the double value. And this is not just happening occasionally, but happens the whole year through in a very stable manner. So every day irradiation is high, and every month we have more than 100 kilowatt hour per square meter of irradiation. This is extremely high, and for that reason, it's interesting to use solar energy in your country. So there is some framing necessary to identify what solar energy we talk about, because we have different sort of conversions: irradiation to electricity, irradiation to heat, and irradiation to both heat and electricity. In this presentation, I mainly focus on photovoltaic conversions that actually cover the irradiation to electricity conversion step. But to be able to use these technologies that are made from semiconductors such as silicon and 3,5 compounds in CIGS materials, we also need system components called BOS that are required for the conversion of the DC power to EC power, to store electricity, and also to transfer electricity to other locations. And this has to be put in the context of applications like the built environment, agriculture, PV and ecosystems, floating PV, and mobility. So this will be a topic of this presentation. There's different sort of applications available yet for photovoltaics. Namely, we know all the pocket calculators and solar lamps that you can put in your garden, and satellites that are powered by PV. But for Indonesia, there's two important applications that are of direct use. Namely, off-grid PV for domestic applications, like for instance solar home systems, but also hybrid systems for community energy supply, and non-domestic applications like repeater stations, water pumping, etc. And then also we have grid-connected photovoltaics, the type of system Kunaifi presented about, which can be used on rooftops, but also in solar parks. Why it's so important to work with photovoltaics in any country? Namely, it's extremely sustainable. At the left side, you see a graph with CO2 emissions by different energy conversion technologies. At the very right, solar PV, and at the left, fossil fuels. And as you can see, solar PV has an emission which is a factor 20 lower than fossil fuel conversions, like for instance coal-fired plants. And also the energy payback time, the time required to return energy used for production of PV modules to actually generate electricity, is extremely short. For instance, 2 years in the Netherlands, 1.2 years in Mediterranean countries, and I'm sure it's below 1 year in Indonesia. So the remaining 25 years of a PV system actually generate electricity for free and without any other energy consumption. Well, and also this CO2 emission is going down with technological advance, so it's only going to be better in the future. In the past, we did studies on the potential of solar energy in Indonesia, not just using irradiation maps, but also converting these irradiation maps to the potential for grid-connected photovoltaics and standalone PV systems. And this map shows the potential for grid-connected PV systems, assuming availability of land, the spread of cities and suburban areas and rural areas, as well as the extension of the grid to certain areas. We wrote several papers about this topic, but also this topic is covered by Kunaifi's book. And this map shows the situation for 2018. Per province, the potential of PV is shown in gigawatt hours of annual production. So you see at the left side of Indonesia a high potential. This may be due to the high population density and the high energy demand. And at the right side, a lower potential because of also lack of grids, for instance, in Papua, but also low population densities and hence low electricity demand. This map has been made for the situation that all PV power can be consumed on the moment of demand. So this is a constrained potential map, leading to a total potential of 73 gigawatt peak of installed PV systems over whole Indonesia that generate 95 terawatt hour per year. This is 40% of the total amount of electricity sold by PLN. But if you weren't constrained, if you would always be able to feed in solar power in the grids, then you would actually be able to generate 18 times more electricity, leading to an incredible potential of 3 terawatt peak, generating 5.2 pentawatt hour. Well, I can't think anymore about what that means, but actually in practice, there will be an overflow of electricity supply by PV systems, and you could become a net exporter of solar power to surrounding countries. Maybe a nice future scenario. But the practice is that hardly any PV systems are installed in Indonesia. In a collaboration with the City Council of Jayapura, Papua, World Wildlife Fund, and ITB in Bandung, we started a project in 2010 on PV systems in Indonesia and realized the grid-connected PV system in Jayapura, which was completely monitored. And it was a very technical and high-end system, and we could evaluate the performance over several years. And we found out, as is confirmed by Konaifi, that the performance ratio was really high for well-performing parts of the system, above 80%, even sometimes above 95%. And this is for a very remotely located system with hardly any technical assistance. So this gives confidence in the technology. But apart from this system, the two systems that Konaifi showed were the only two other systems in Indonesia that have been monitored that well. Knowing that PV systems can be well applied in grid-connected situations, then you can also think about using photovoltaics in the built environment, because there you have grid connection. And then it could be interesting to integrate photovoltaics in buildings. This is what we call for building integrated PV, BIPV. At the left side, you see Schelle in Switzerland with a roof integrated BIPV system. It nicely extends to the edges of the roof. And below it, you see skylights with transparent or semi-transparent PV modules that let light in, but also keep sunshine relatively well out. In the middle, you see colored PV modules, also made in Switzerland, that are provided in gray, gold, and blue, and purple. And at the right side, a vision on the Tesla home with a Tesla car and a Tesla roof, which consists of solar roof tiles. So it's really interesting to consider this sort of applications in Indonesia maybe as well, because with the coloring, transparency, and form-giving possibilities, you can integrate photovoltaics really well in buildings. At UT, we conduct research. We have not explored Indonesia yet, but for instance, we conduct case studies on building integrated PV. In this case, for instance, a building in Texas, where irradiation is as high as in Indonesia. And we can import, for instance, models of these buildings in 3D modeling software and apply solar potential calculations to it, for instance, in software called BIM Solar. And there at the bottom right, you see the building, very small, with above it all the sun paths over the whole year. And by such a simulation run, you can actually determine the total irradiation that is received by facades and roofs. In this case, this is a very big building. We have actually estimated that this could contain 440 kilowatt peak of PV systems. You would generate close to, let's say, 250 kilowatt hour in day, in spring, by facade, but more on the roof. Because of the position of the sun. So there is a very interesting situation. The closer you get to the equator, the more important horizontal surfaces will be in efficiently converting solar energy towards electricity. While in more northern regions at higher latitudes or more southern latitudes, the facade will generate more electricity. So for Indonesia, it's interesting to look at roofs of buildings instead of facades. Another option is to apply solar cells in mobility applications, like for instance, vehicles, boats, e-bikes. And here I would like to refer to the presentation by Max Ammer. It's, I think, well possible to apply PV systems to the roof of your newly constructed catamaran and make it run partly on solar energy. In these examples shown here, real products are shown. I'm really proud to show the Dutch Lightyear 1, which is a passenger car, which is greatly powered by solar cells integrated in its roof and hood. In the middle, a PV sports boat that has been realized in a project that I conducted with the Applied University of Science in Leeuwarden. On the right side, you see a solar-powered e-bike that was also part of a project at University of Twente. Adding to this, you can also charge electric vehicles or electric boats with charging stations, as is shown at the left top of this slide. In that situation, you try to actually reduce the dependency of fossil fuel supply chains, which are sometimes very difficult, particularly also in Indonesia, in islands, by lower cost electricity from PV systems. And also then that way you have an environmental benefit because emissions will go down. However, it depends on the carbon intensity of the grid. At the bottom, you see at the left a graph with emissions of electricity grids in various countries, among which Latvia, for instance, the Netherlands, but also the average European grid. And there's big differences in the emissions. I think Indonesia might be compared with the grid in Latvia because you have a lot of coal-fired plants, so the emissions would be about 1,000 grams CO2 equivalent per kilowatt hour produced and available on the grid. Well, at the very right, you see a PV system that emits only 30 grams CO2 equivalent per kilowatt hour. So if you would use the solar power instead of electricity from the grid to charge electric cars or electric boats, then you would gain a lot in emissions by transportation. And at the right, you see then a graph which shows the difference between the emission between a gasoline internal combustion engine as compared to electric cars in various locations in Europe. And the yellow arrow indicates what could be the potential reduction of emissions due to charging with solar power instead of electricity from the grid. And of course, you see that the effect is then best in Latvia, where you replace coal-fired electricity generation by solar power. Okay, at UT, we conduct modeling activities on estimating the energy balance of charging with solar power by charging station of electric cars. And we haven't explored yet the situation for Indonesia, but I would be really curious about what would be the effect in the Indonesian conditions. But at the left, for instance, you see for the case of Australia, where we also have a very high irradiation over the whole year, what would be the consequence of 100% charging of electric cars, like for instance, Nissan Leaf, with solar power. And then, for instance, you see in the blue bar charging of the EV battery, which happens all year through in a proper way, except for winter, there is a little dip because of less irradiation availability, but that wouldn't be the case in Indonesia. And you could do that with a 4 kilowatt peak PV system with a 10 kilowatt hour battery. This would lead then to a significant reduction of CO2 emissions of more than 93%. This is amazing. I think this is something to be considered for cities with a high pollution level due to transportation.
Angel, you have 1 minute.
Yeah. I have now a conclusion slide. So, coming to the conclusions, thank you for reminding me about that. So, summarizing what I told, Indonesia has an extremely high annual radiation over the whole year of 1,800 kilowatt hours per square meter per year. With very modest variation, so you should actually use solar power in your energy system without any concern. And also, I've shown that grid-connected PV systems have a very big potential and could cover potentially all electricity demand in Indonesia. You could even become a net exporter of PV power to other countries. And you can reduce CO2 emissions easily in the built environment if you would apply PV systems on roofs. You could apply them in PV-powered boats and electric cars. It's technically feasible and reduce actually dependence on fuels and decrease CO2 emissions significantly. It's 93%. So it's a pity that only limited experiences exist with PV applications in Indonesia. And I think for that reason, given this background information, it's really relevant that more research should be executed. And also implementation could maybe be speed up. Thank you for your attention. I will stop sharing my screen and put up the general presentation with several questions to the audience. unless you have questions for me. But, oh, sorry, this is the wrong one. Then we go to the other one. Sorry, it has disappeared. One second. Yes. So we have still 20 minutes for the general question answer session. I would like to ask the speakers to unmute themselves so that we are open to any discussion item. So Penny, Max and Kurafi, can you unmute yourself?
Yeah.
And we can hear you. So we have prepared several questions for the audience. And I would like to ask the audience what you think about how well PV solar systems can be integrated in the energy system in Indonesia after having seen our presentations. And please feel welcome to unmute and actually also tell what you think and ask a question to one of the presenters. And don't feel shy. Nobody is available for question. Then I will change this. I would like to make this a panel discussion. So I would like to ask Penny the first question. How do you believe that PV solar energy systems can be better integrated in Indonesia? What is the way to move forward in the next 10 years?
Yeah, I think it's a very nice questions. Like in PLN itself, we believe that PV solar energy is one of our option how to achieve to reduce our cost of productions. Because in Indonesia itself, the potential of irradiance is very higher, and I think it's in line with government's policy today in Indonesia that we have to achieve minimal 25% of renewable energy, and it will be supported by PV system. And not just for PV system, but we have several options of energy. But so far in PLN, we a little bit focus more with PV because the transfer of energy and it's more promising than the other options.
Thank you. So there's also active policy at PLN to stimulate PV systems in islands.
What?
There is an active policy in PLN to stimulate a better implementation of PV systems in islands.
Not focusing on only on PV system. There's no regulation only for PV system, but we are focusing more on the general renewable energy. It's depend on the locations, like the potential on that island, which the energy source will be more maximum in there. That's the regulations.
Okay,
So far.
thank you. Yeah, I would like to ask the same question to Max Amar. How do you believe PV solar energy systems can be better integrated in Indonesia?
For the PLN, of course, it's a different story because that's the state, the supplier. But for private companies, sometimes you see a problem and you actually already kind of know how you could solve the problem, but often it's also a financial matter. If you buy a generator, you spend a little bit of money and you can immediately have the energy you need, but you pay, of course, per day. In the long run, it costs you a lot of money. With electricity, you have to invest in forehand, and over the long run, you will save a lot of money. But sometimes companies do not have that money. So if somehow there would be a way that banks or financial institutions would give very, more attractive loans. In Indonesia, the loans, if you would get one, are extremely high. So that is one of the things that the government could work on, or maybe you have banks that are green loaning banks. Maybe that would be a stimulus, because I know from my experience that sometimes I know there's a solution, but we didn't have the money at the time. That is one of the problems.
And also like to edit some more about the questions before that Mr. Henry maybe say that why it's difficult to increase the renewable energy percentage in Indonesia. One of them is because of unfair of the subsidy, whereby the renewable energy is subsidized as much lower rate than fossil energy. As the result of this unfair price, renewable energy is not affordable for most of people and industry. In addition, the government and industry still have not fully invested in research and development of renewable energy technology, where most of the technology is imported and role of the domestic industry is still very minimal. That's why the price still higher for renewable energy in Indonesia. And also the government still treat the renewable energy as a small scale technology rather than as a major contribution to energy stability and energy access in Indonesia. That's why I think the things that make the progress of renewable energy is a little bit slow down than the target that the government state. I think the regulation need to be improved for that.
Thank you, Penny. Kunafi, you also have given a lot of thought to this question in the past years. What do you think that should be done to better integrate PV systems in Indonesia?
Yeah, I think Indonesia doesn't have any other option except for renewable energy, because previously Indonesia is heavily depending on fossil fuel. Indonesia was one of the important member of OPEC, because we export more oil than imported. But during the past more than 10 years, Indonesia has been net oil importer, which is the reserve is much less than the demand inside the country. The same story is happening to gas, natural gas, because the conversion from oil to gas has been exploiting gas much faster. A bit longer hope can be put on coal, because we have a lot of coal. But you know that international community doesn't like coal due to the environmental effect. So Indonesia doesn't have any other option. The available option is renewable energy. That's why I believe that renewable energy and also PV system will become one of the important sector in Indonesia's future electricity sector. However, again, policy is one of the determining factor in this case.
May I also say what I think, because even though I'm leading the question and answer session, also conducting research on this topic. So thank you for giving me this liberty to express my opinion. But what I've seen in the past 20 years is that there is a very interesting interaction between the issue mentioned by Max on investments. In the past, PV systems were quite expensive, but still now it's of course a bigger investment that you have to do to guarantee your electricity supply in the next 20 or 25 years. And then that's related to supportive mechanisms provided either by the government or electricity utilities. And there is actually no connection between those. And it could be helpful, for instance, if government would provide an investment subsidy that offers companies or maybe citizens to acquire their first PV system and then pay it back to the government as part of their monthly electricity bill, for instance. That sort of mechanisms don't exist yet, and I think that would be helpful to further stimulate the widespread use of photovoltaics, but also other renewables, because if it's can be done for photovoltaics, then you can also apply it to biomass systems or to wind parks. Is there anybody in the audience who would like to reflect on this question and give their opinion and thoughts, share their thoughts? No? Okay. Then we have another question, which is really interesting. I try to put it on the screen. Yeah. Actually, these are the same questions, but in a different way posed. Yeah, what are your thoughts about other renewable energy technologies? And if these will be implemented, what would be acceptable cost for the citizens of Indonesia? Penny. Could you unmute yourself and tell what you think about this?
Oh, okay, about the acceptable cost for it can't be like what is the acceptable cost, because we have to have analyze about the data and everything. It can't be like which one is acceptable, but in the range is should be more lower than the steam power plant and our biggest power plant so far. So now I think our production cost is about, especially in island in Bangkoblitu itself, it's about 2,000 rupiah per kWh. So it should be down there if we want to have a revenue and long-term sustainability of the power plant that we will install in this region. I think something like that.
Thank you. Kunaifee, what do you think?
Yeah, beside PV system, I believe that biomass energy is the next biggest potential of renewable energy in Indonesia. The good thing about biomass is that we as a human can control it. We cannot control when the sun rises and when the sun sets. We also cannot control when the wind blows and not. But for biomass, we can decide where to plant trees, energy crops, or something like that. And Indonesia is a good place for biomass because of the rainforest tropical climate, and also the biodiversity of Indonesia is one of the best in the world. So the technology normally can follow the fuel, and the fuel can follow the technology. When we, for example, want to use biomass as a fuel, as biofuel or bioethanol, something like that. What about the cost? I have no idea what would be the acceptable cost, but I have a feeling that the cost of electricity in Indonesia can be increased a little bit in the coming years compared to the current cost.
Thank you, Kunaifee. Max, what do you think about these questions?
I have maybe a different question that I want to pose, and a question that maybe Penny can answer. I heard that there is a presidential decree, and I would like to know if it's correct or not, if I'm mistaken, but that if, for instance, a kabupaten generates green energy, that the PLN is by this presidential decree ordered to buy that green energy. Is that a true story?
Yeah. So it's like for government, they want to increase the use of the electricity, and one of them, the way is, like you said before, the PLN not sure, but they encourage PLN to push PLN to buy from, we call it IPP for renewable energy.
Because the Bupati in Tamrau is one of the kabupatens in Papua, realized two high-head hydropower installations of 800 kilowatt each, and he is now selling that energy to your PLN. So I thought it was very encouraging thing to see that the government, by this regulations, make it possible for a person like a Bupati to invest in green energy. This could, of course, be head hydroelectric, but it, of course, could also be PV. So that means potentially that the Bupati in another area could himself invest in the PV system and then sell it to your organization. So that sounds to me like a very wonderful potentially thing, and maybe industry or other companies could invest in this. This is just an idea.
Sure, it could be, but we still have to. There's a range of the price. Everybody could sell the electricity to PLN, but we have a limit price. We will evaluate if it past the limit of the energy price in that area. It couldn't be. It should be more lower than the higher production cost in that area.
Okay, that is understood. But what I understand from the Bupati in Tamrau is actually he's selling it for an acceptable price, and now his area actually gains some income by doing this. So it's financially interesting for him, and I think he was the first one in the whole of Indonesia to do this. So I find this quite an amazing person with very interesting ideas.
Yeah, it could be in PLN.
I also think it sounds very promising, and it has to do actually with the next questions, because always we want to know how end users play a role in this sort of processes. But Max, as you mentioned, the end user could be Kabupaten, and this person could take the initiative to deliver electricity to the grid of PLN at lower cost of the maximum that's set by PLN. But in that way, you can stimulate affordable renewable energy technology to be connected. And from one thing comes another thing. Knowing that Konaifi has conducted a lot of research on end users, I would be interested in finding out what he thinks about involvement of end users in the implementation of renewables and PV in specific. Do you think it's a good plan to involve them, or is it just a matter of government and PLN?
Yeah, okay, can you hear me now? Because now I'm using headphone.
Oh, okay, but you can also hear your background noise.
Yes, yeah. Yeah, because it's almost time, so
yeah.
Okay.
So I would like to apologize then, because the sound is maybe better to mute, and so we are at the end of the session. So could everybody mute themselves again? Thank you. So I would like to thank the speakers, Penny, Max, and Konaifi, for their great presentations and inspiring discussion we had. I would also like to thank the audience for being patient with our changes of presentation modes and the screen sharing trouble. And I hope that you have an interest in a follow-up meeting. And if you have interest, just let us know by the chat window, and we might like to connect with you in the future. And also, if you have questions, please don't hesitate to contact either me, Penny, Max, or Konaifi, because we like to talk with you about these sort of topics and learn from your experiences, whether you're in Indonesia or the Netherlands. Thank you.